In an era when so many everyday objects feel fragile and disposable, the idea of a car designed to endure for decades without becoming a source of frustration feels almost unreal. Yet that is the promise behind the upcoming Tesla Model 2, expected to arrive in the middle of this decade. The goal is not merely to introduce another affordable electric vehicle, but to redefine how long a car can realistically remain reliable. Instead of accepting breakdowns, wear, and gradual decay as unavoidable, the philosophy behind this vehicle is simple and radical. Remove problems before they ever exist. When fewer things can fail, ownership becomes calmer, cheaper, and far more predictable. That mindset begins long before a single car touches the road. It starts inside a manufacturing environment engineered to eliminate chance. The Model 2 is assembled in a production line that operates more like a scientific laboratory than a traditional factory. Hundreds upon hundreds of sensors constantly observe every step of the process, tracking torque, alignment, vibration, and microscopic positioning in real time. If anything drifts even slightly outside the allowed parameters, the entire system pauses automatically. There is no improvisation and no fix-it-later mentality. The expectation is that perfection must be achieved before the vehicle ever leaves the factory floor. One of the most telling examples of this obsession with precision lies in something most drivers never consciously think about: panel gaps. In many conventional vehicles, relatively wide tolerances are accepted as normal. Over time, those gaps allow noise, dust, moisture, and vibration to creep in. In the Model 2, those spaces are reduced to nearly imperceptible margins. The result is a body that feels solid, quiet, and sealed, even years down the road. This level of precision is not cosmetic vanity. It directly influences how the car ages, how it sounds, and how it feels after countless miles. To achieve this consistency, Tesla relies on advanced visual systems powered by artificial intelligence. Cameras analyze every surface and angle as the car is assembled, instantly flagging even the slightest misalignment. It is as if the vehicle is being continuously sculpted rather than pieced together. The benefit goes beyond appearance. Precise alignment improves aerodynamics, reduces wind noise, and minimizes the subtle vibrations that slowly loosen parts over time. The driving experience remains calm and refined far longer than what most drivers are accustomed to. This vigilance is reinforced by an advanced statistical control system that monitors the entire production process from start to finish. Instead of reacting to defects after they appear, the system identifies trends before they become problems. Tiny changes in temperature, torque, or vibration are detected early, allowing engineers to intervene immediately. This predictive approach dramatically reduces the likelihood of long-term issues that would otherwise surface months or years later as rattles, leaks, or electrical faults. Every completed vehicle then undergoes exhaustive testing. The electrical system is examined in its entirety, from high-voltage components down to auxiliary circuits that many manufacturers treat as secondary. Nothing is overlooked. Afterward, the car faces an intense water exposure test that simulates prolonged heavy rain from all directions. If even a trace of moisture finds its way into the cabin, the vehicle is rejected for correction. This process helps prevent the kind of slow, hidden damage that can lead to mold, corrosion, and electrical failures years after purchase. Mechanical alignment receives the same level of scrutiny. Robotic systems measure door hinges, seat rails, and moving components down to microscopic tolerances. The force required to open and close each door is calibrated precisely. This attention ensures that even after years of daily use, doors still close smoothly and seats continue to adjust without resistance or noise. These may seem like minor details, but they are often the first signs of aging in an ordinary car. Eliminating them preserves the sense of quality long after the novelty is worn off. All of this groundwork serves a larger purpose: creating a vehicle that does not gradually deteriorate in ways owners learn to tolerate. Instead of accepting creaks, misalignments, and intermittent malfunctions as normal, the Model 2 aims to prevent them entirely. It is an approach that feels almost defiant in a world accustomed to planned obsolescence. When discussions turn to the longevity of electric vehicles, the battery inevitably becomes the focal point. Traditionally, it's viewed as the component most likely to limit a car's lifespan. Here again, the Model 2 challenges expectations. Tesla is moving toward an aluminum-based battery chemistry designed for extraordinary endurance. The projected lifespan reaches into the realm of millions of miles, far beyond what most drivers will ever accumulate. Rather than degrading rapidly with each charging cycle, this chemistry maintains stability over an exceptionally long period. The internal structure of this battery is engineered to distribute stress evenly, especially during fast charging. Instead of concentrating electrical and thermal pressure in a single rigid layer, the design spreads it across multiple layers that work together. This reduces internal damage and allows frequent, rapid charging without accelerating wear. For owners, this means convenience without the lingering anxiety of silently harming the battery. Thermal stability is another major advantage. The battery operates efficiently across a wide range of temperatures, maintaining consistent performance in both extreme cold and intense heat. Conventional batteries often lose capacity and efficiency under these conditions, but this system is designed to remain calm and predictable. Safety improves as well. The chemistry greatly reduces the risk of thermal runaway, meaning that even in the event of failure, the battery is far less likely to ignite or propagate heat uncontrollably. Beyond durability and safety, there are economic and environmental benefits. Aluminum is abundant, widely recyclable, and less dependent on fragile supply chains. This helps lower costs and supports large-scale production without sacrificing resilience. The result is a battery that feels less like a consumable component and more like a permanent part of the vehicle. Instead of planning for an expensive replacement years down the line, owners can reasonably expect the battery to outlast most other parts of the car. Supporting this long-lasting energy source is an equally radical approach to vehicle structure. The Model 2 makes extensive use of massive casting technology to form large sections of the chassis as single pieces. Traditional cars rely on hundreds of welded components, each joint representing a potential weak point. By drastically reducing the number of connections, the structure behaves more like a single solid object. This improves strength, consistency, and resistance to fatigue over time. The rigidity achieved through this method is remarkable. The body resists twisting and flexing far more effectively than conventional designs. This stiffness has practical consequences. When a car flexes less, doors stay aligned, panels remain tight, and interior components experience less stress. Noise is reduced, vibrations are dampened, and the entire vehicle feels more composed even after years of use on imperfect roads. Corrosion resistance is also addressed at the structural level. Advanced protective coatings shield the metal from rust for decades, even in harsh environments where road salt and moisture typically accelerate decay. Rust has long been one of the silent killers of otherwise functional vehicles. By largely removing it from the equation, the Model 2 preserves not just appearance but structural integrity and safety far into the future. This simplified structure also improves manufacturing efficiency. Fewer parts mean fewer opportunities for errors, lower energy consumption, and more consistent quality. It reflects a broader philosophy of solving problems at their root rather than managing their symptoms. Instead of reinforcing weak joints or compensating for inevitable misalignments, the design eliminates many of those vulnerabilities altogether. Attention to longevity does not stop with the major components. Tesla has re-examined parts that traditionally wear out first, focusing on the quiet failures that slowly erode the ownership experience. Suspension components, for example, often rely on rubber elements that harden and crack over time. In the Model 2, these are replaced with advanced composite materials that retain flexibility and strength over enormous distances. The suspension remains quiet and compliant long after conventional systems would begin to complain. Wheel bearings receive similar treatment. By combining ceramic and steel elements with specialized lubrication, friction is reduced and lifespan extended significantly. The benefits are twofold: improved efficiency and fewer mechanical failures over time. Hinges and latches are constructed from alloys designed to resist loosening even after countless cycles. Doors continue to operate smoothly without developing the play and noise that so often signal a car's age. Even seat mechanisms are engineered for endurance. Precision calibration and wear-resistant treatments ensure that adjustments remain smooth and reliable year after year. These details rarely appear in marketing materials, yet they define how a vehicle feels to live with over the long term. When they work quietly in the background, ownership becomes effortless. Taken together, these choices paint a picture of a car designed not merely to function, but to endure. The Model 2 represents a shift away from the assumption that vehicles must inevitably degrade into a collection of minor annoyances. Instead, it embraces the idea that careful engineering, obsessive precision, and thoughtful material choices can dramatically slow the passage of time. In doing so, it offers a vision of car ownership that feels refreshingly calm, predictable, and enduring in a world where such qualities have become rare.